Good morning, gentlemen. Today is Thursday, April the 30th, and today we will be talking about the last lesson in our brief unit on electromagnetic applications. You'll be happy to know that there's no math in this one. All right. Um, so today, what we're going to talk about is the idea of lasers, and although this is an application of electromagnetism, it kind of is a nice little introduction into the unit that we'll start next week, which is all about waves, wave energy, and light. So lasers are kind of neat little tricks. Everybody's got one in their pocket. The low energy ones typically are red light or green light. And some of you own lasers of this sort, little pocket lasers. I've got one in my classroom that I use to point at the whiteboard occasionally. But in any event, essentially what a laser is a machine where you've got some sort of energy source, which essentially is bumping electrons up into a higher energy level. Those electrons then are stimulated by photons, and the photons then move up and down and are reflected on a surface. And when they get reflected on a smaller surface between two mirrors, eventually they will be emitted out one end as a very narrow, low beam of light. Now, a couple of things before we get into the details of this. First, the word laser is actually an acronym. It stands for light amplification by stimulated emission of radiation, all right, LASER. And it is the laser light is by definition monochromatic, one color. So you get a laser that's red light or a laser that's green light or whatever color you happen to want. That depends on the source of the electrons. It depends on a number of other things. But it's also a very coherent beam, meaning that it sticks together. It doesn't spread out. Your typical flashlight, it works really well when you're close to the object that you're shining the light on. But when you try to shine a flashlight across a large field or something like that, the light is diffracted and spreads out so much that it doesn't really do you any good over that long distance. So that's the idea behind a laser. Now, laser light is useful and important for a variety of different reasons. Pointing at a whiteboard in a classroom, for example. But it's not something that's going to light up a room or that sort of thing. All right, so it's a different kind of light. Now, let's talk about how this works. All right, usually energy causes electrons to be excited. All right, you add energy to an atom, and its electrons jump into the next energy level, or second or third energy levels. And when they drop back down into the more stable energy levels, they emit light. But that light is not uniform. Different atoms, different elements will emit different colors of light when their electrons jump back down into a lower energy state. So in a laser, what happens is that the electrons themselves are pumped up using energy, typically electromagnetic energy, into a stable, excited state. This can come from a battery, it can come from a plug, it can come from a variety of things. But the electrons are kept in that excited state, and they're maintained there so that they don't drop back down, unless they're stimulated by a photon. Now, a photon is a particle of light. We'll talk about that more in the next unit, but just photons are essentially units of light. And when a photon stimulates the electrons, they emit two more photons. Okay, so we're magnifying the light now. And those photons then stimulate more electrons, which then emit more photons, and so on and so on and so on. And so this multiplication of photons is repeated many times, and we call this process amplification. Now, eventually, and I'll go back to the picture in a minute, the photons are reflected back and forth between two mirrors. And on one mirror, there's a tiny little hole that allows light to pass through. All right, and that hole emits the coherent beam of monochromatic light that we see as the laser beam. Okay, so let's go back, to the picture. All right, the mirrors are here and here, and the one on the right side here has a tiny little hole in it. And so the come on, the light is originally fired out here, but when it starts striking the two mirrored surfaces, you can see that its amplitude has decreased considerably. However, it's still moving at the speed of light, and it bounces off of this mirror on the left and sometimes bounces off of this mirror in the right. But if it hits the mirror on the right at just the right point where the hole is, it then will emit a very bright, high-powered signal that doesn't break up, doesn't diffract, doesn't spread out as time goes on. Anyway, so that's just a brief introduction to lasers. We will talk about lasers in more detail when we get to the unit on, or the section of the unit on light. Okay? All right, fellas. So today is Thursday, which means that tomorrow, my friends, is going to be a quiz. Tomorrow's quiz will be on combined circuits. All right? I sent out a practice combined circuit. Make sure that you have a look at that, try to calculate it. I will post the answer key to that problem this afternoon on the portal, or maybe I'll just email it to y'all. I don't know. Actually, that's probably easier. But make sure you check it. Make sure you know what you're doing for tomorrow morning's quiz. All right, fellas. Happy Thursday.